From picture. Today I'm going to explain what is order statistics. So in the definition you can say here, it says that the ith order statistics is defined as the value that comes in the ith position of the n element sequence when the sequence is sorted in increasing order. What does that mean? That means let me explain. So let's say if someone say, hey, what is the first order statistics in this array, then you can say, hey, this is the first, which is 1. This is the lowest here. What is the second lowest number basically in this array? Then you can say, hey, this is 2. What is the third lowest number? Then you can say this is 5. So this third, fourth, this is called ith order statistics. So how could we solve this problem? The problem you could easily solve by sorting this order. So once you sort this order, then obviously you will have a number, and then anytime if there is a ask to find out the whatever that lowest number, let's say 5th lowest number or 6th lowest number or 7th lowest number, you simply go and basically directly you can fetch that value from the index of that array in that particular position would be the ith sort of order statistics, right? What does that even mean? So if I copy this one and paste it here, then probably you would understand. So now this is the number here. Now if I go and sort the above one, so if I sort this one, then we would find, we would find this. So first would be 1, right? Then second would be 2, then 5, then 6, then 8, then 9, then 10, right? Now when you sort this, then if someone say, hey, what is the second lowest number, so you can simply go and fetch the second position of this array. So basically the index of any number or I position would be the index of that particular array. If someone says what is the third lowest number here, so you can simply say this is the third lowest number, this is the third position. What is the fourth, what is 6th? So you just need to sort this one, that's it. So once you sorted this this array, then you can quite easily find it out. Now you also need to make sure that when the terms like time complexity or space complexity comes in, then you have to make sure that you are basically not going order of let's say n square. So no, you should not basically, because then you will not get it approved from the examiner, because maybe he's not he's not in a situation to give you full mark if it goes to order of n square. So you have to make sure if it would be really good if you basically complete it by order of n. I don't know if it is possible or not, maybe possible, but at least order of n log n. If that the time complexity you can achieve, then I think that would be great. Now how we are going to solve this problem? Well, you can solve this problem by just simply sort an array and then simply go and fetch it from that particular index, right? You can slightly improve this one as well. So how we are going to improve it, which is basically I explained here. This algorithm, this is a quick sort algorithm, so we are basically applying same kind of quick sort here. See if I copy this one here, paste it here. So this is the algorithm that this is the solution basically that we have put in place in my quick sort video that I posted before. So we can basically apply similar kind of thing here, but slightly differently. So what we need to do is we need to basically check here. So when this mid position or in a quick sort, we basically need to partition the number. So it can call it partition number or pivot number or mid number, whatever you call it basically. So you need to check whether this is basically the so this mid is basically an index, right? So if you see here, returns the I is basically the index. So we are basically putting initial value 0, and then there is a loop that basically goes through each of the element and find out the number, basically the partition number, which is a number that has all the lowest value on the left side, on the upper value on the right side, right? So this particular value, once we find out, then we basically return the index of that particular number. So once the index is returned, and that index is basically picked here, so if you just simply check if this index is your one. So let's say you also ask for this integer k. K is basically the ith lowest number in this array that you are basically figuring out. So if mid is equal to k, then basically you can simply return it here that hey, this is the number basically. So if mid equal to k, then you can simply return the collection a of k. So this is, or a of mid, whatever it is. So this is basically the number you are getting. That's it. And here you can say if left not equal to right, I think this is the algorithm. And then here else, so if mid equal to k, then return, this is basically the result. Now if your mid position is, if mid position is less than k, then you basically need to do else. You basically need to do so same logic, same thing you could apply here, and you could possibly solve the problem quite easily. So what we're doing here basically, so we could basically get the quick sort running, and then once the quick sort is done, then you can basically go and grab it from the nth position or I position. But we are basically improving slightly here in this algorithm. So what we are doing is we are basically doing the partition. At the same time, we are checking whether my mid or that pivot index position is basically the one that I am asking. If it is true, then just simply return it from here. That should be it. And that way what will happen is you definitely get an improved edition or version of the algorithm. All right, so the solution that I have here is this. So this is basically the algorithm main part, which is called quick select. So yeah, so first of all you need to check if left equal to right, means you basically have only one number, one element in the list, so you don't need to do anything else, just simply return it there, because that would be definitely the number you're looking for. Now if let's say it is not, then what we're doing is we're creating the pivot index or mid position by doing the partition. So once the partition is done, then how we are doing the partition and everything, please follow my earlier video, which is quick sort algorithm. I'm gonna put the link in the description so that you can basically go and check that one. Now you need to check if k means that kth position, kth lowest number that you are asking. We need to check if this is the one, this is the same index of the pivot index. If it is there, then just return it. This is the result that I told you before. If it is less than k, is less than the pivot index, then what you need to do is you just need to call the quick select with basically left means 0, and you can maximum go that pivot index, which is the mid position, -1. And then else you basically need to start from the mid position or pivot index +1, and then until the right means whatever the last index you have. So yeah, that's it. So this algorithm I'm gonna put in the description so that you can get it from there, and I guess that's it. So I guess you have now understanding like what is in this what are statistics and how to solve this problem. All right, I'll move to other algorithm in my next video. Till then, bye bye.